So we've just finished going through the notes, and if you're struggling on this classwork or classworks in the future, this video may help. I'm going to show you all how to use a program called Desmos, and then we'll use that to help with some of the problems in the classwork. And I think y'all will like it quite a bit. So I'm going to go ahead and share my screen with you all. We're going to get started with using Desmos and where you can find that. So this is my Schoology page. If you go to this, you'll see it's set up just like this. You can click on this link that says Desmos Graphing Calculator. This is the version we are using. They have two versions. It'll show up in Schoology, and you can use it here. If you don't want to use it here, like you want to pull it out as a tab to use, that's perfectly okay. For this, I'll probably pull it out as a tab to use and split screen it with Schoology. So now that I have Desmos up, I'm going to pull up the classwork, 3-2 classwork. And actually, I have, here we go. So let me zoom in a bit. Don't worry about the yellow highlighted circles. Those are just reminders for me. So number 1 says, and I'm actually just going to full screen this all the way. Number 1 says, find the domain and range of each relation and then state if the relations are functions. So this is going to take us back to that first set of notes we did in Unit 3, learning what a relation is, how to write those out. And then that second set of notes, which is what this classwork is associated with how to determine functions. All right. So domain, I'm going to change up my colors for domain and range because I heard those were kind of hard to see in the video. When I go to write my domain, my domain, first off, if I think back, my domain, it's going to be my X. It's going to be my input. It's going to be on the left side of the mapping diagram. Those are the things that I know when I'm thinking domain. So I'm going to keep that in mind as I go through this problem. Oops, curly brace. Okay, so my domain is going to be a list of all of my X values. So I'm just going to go ahead and type X over top of all of my X values to help us in our pursuit of knowledge of domain and range. So here we are. These are all of our X values. And while I'm at it, I might as well go ahead and type in the Y values. Let's make those, I'll keep those green. Y here, Y here. And you don't have to do this on your set of classwork. This is just so you all can see my thought process. All right, so we have our X and Y's listed. I'm going to go back down here to my domain and type this out. Now remember, my domain is all of my X values in that listed set of ordered pairs, okay? So my X values. So I have 1, 2, 3, 4, 5 X values. I'm going to write them in order from least to greatest, and I'm not going to repeat anything that's been repeated more than once, okay? So let's go ahead and write it. The smallest number I see is -4. And then I have -4 twice. We have -4 here. Oops. We have -4 here. And then we have -4 here. All right. So we're not going to write that -4 twice. We're just going to write it once because that's how we write domains and ranges. We only write it once. I'm going to skip that one. Then I'm going to go to the next smallest value, which is going to be 0. And then it looks like it's going to be 2. And then 3. All right. And there we have my domain listed. Now let's go ahead and write out the range. For the range, I'm going to use this bright pink color. Hopefully you can see this in the video. So my range is going to be similar to my domain, except instead of X values, I'm going to write out my Y values. Everything else about it will be the same. They're not going to repeat. We're going to write them in order of increasing value from least to greatest. So the smallest one I see is 0. And then I've got a 1. And I've got a 1 in here twice. This point is repeated, -4, 1, -4, 1. This is in here twice. So I'm not going to repeat those values when I go write it in my list. I'm going to only write it once. So 0, 1. Next, I have 4. And then finally, I have 5. Okay. So I've written out my domain and I've written out my range. Then it says state if the relations are functions. So is this relation a function? Now let's think back to what our last set of notes said. Our last set of notes said a relation is a function if there are no repeating x values. In short, like that's the quickest way to think about it. If none of our x values are repeating, then it is a function. Do we have repeating x values in this? Oh, yes, we do. We got a -4 here and a -4 here. So this is, let's put it in big bright red letters, not a function. All right. So I'm not going to go through all these. I'm going to go through some of them to just assist on some problems. Number 1 is one. I'll go through number 3 real quick. I'll start you off with number 3. I think once you get started, you'll understand how to do it. Number 3 says, is this a function? Yes or no? Circle 1. Now, this one is interesting because it's given us ordered pairs, or it's given us points on the graph. And from these points on the graph, we're going to write out our ordered pairs and then look to see if that's a function. Okay. So this one here, this first point, this is going to be -2, 2. I'm going 2 in the negative x direction and 2 in the positive y direction. So there's going to be -2, 2. And remember, with these, you must write them in parentheses. Otherwise, we don't know that they are actually ordered pairs. Okay, this one here, I go -1 in the x direction and then 3 in the positive y direction. And I'm going to change this color so these are all different colors. So I have parenthesis -1, comma 3. That's this point. My next point, and I want to try and set these up so you know what they go to. My next point is going to be this one here. It's 0 because I don't move on from my origin in my x direction, and then I go down 1, so 0, -1 for my y. Let's make this one red. Parenthesis 0, comma -1. Close that parentheses. Here we have 1, 2. And I'm running out of colors, but that's okay. I got just enough, I think. 1, oh, parenthesis. Don't forget that parenthesis. 1, comma 2. Oh, I don't like that one at all. Hopefully you all can see that. And then finally, I have this one up here. We have 1, 2, 1, 2, 3, 4. 1, 4. Okay, this one's hard to see and count because of the positioning, but this one should be 1, 4. If I miscount it, forgive me. Okay, so now that we have all of our, oh, that's not 1, 4, that's 2, 4. Glad I caught that before we went on. Okay. So now that we have all of our ordered pairs listed for each of the points on the graph, we can put in the domain and range. You all know how to do that because we just did that above. And now we're going to answer the question, is this a function? Yes or no? Does this have any repeating x values? If I go to look at this, I see -2, 1, -2, -1, 0, 1, 2. I don't see any repeating x values, so this will be a function. Let's use this color. So this would be a big old yes, and this one, number 1 would be a yes as well. That would also be a function. Number 4, you're going to follow the arrows from the mapping diagram to write out your ordered pairs. If you can't tell from looking at this where this is going to be a function, you're going to write out your ordered pairs from the mapping diagram and then write your domain and range. Number 5, you're using that vertical line test, VLT. The number 6 is the fun one to me. Number 6, we get to use our Desmos calculator. So like I said earlier, when you go to use Desmos, you're going to come to my Schoology class, and it says Desmos graphing calculator. That'll be right there, or maybe even higher up. Once I'll probably move all these down, and this will be that first link in Schoology, in the Schoology folder. You can click on that. It'll have it up in Schoology, or you could do what I did, which was to open it on the side page. So I'm going to set this up so I can walk you all through it. Number 6 says, if f of x equals 3x squared plus 4, find the following. And this little Desmos here won't be on your copy. I just wrote that in there so I could remember to show you all Desmos. All right. So when you go to Desmos, like I have it up here, first off, let's go ahead and write the problem, just so you all are familiar with how that works. You're going to type it in exactly as you see it. F parentheses X parentheses, close that parentheses, equals. And if you are doing this on your phone or something like that, or on a device where you don't have an actual keyboard, you can hit this little button at the bottom that says show keyboard, and it'll bring up a keyboard. So I'm going to keep on typing. I can hit 3X, and then this one here, this A squared, is going to put that squared button on it, or that squared function on it. So I can keep on writing 3x squared, and now I have plus 4. Okay, so that's a pretty cool thing. And it's showing us this function here. Okay, it's showing us this function here. So now that I have this function typed in, I can click on this next thing and just type f of 2. What is f of 2 going to be? It's asking me in the question what f of 2 is. Oops. It's asking me in this question what f of 2 is right over here. And so I type f of 2. After I've typed in my function, I type f of 2 in, and down here it tells me it equals 16. So from that, we can see that f of 2 equals 16. All right, I'm going to change that color because that one's kind of hard to see. F of 2 equals 16. And we can go ahead and do that with this next one. It says 3, f of 3, f of 3 equals 31. See how easy that was? Oh, that was so easy. F of 3 equals 31. It's taking all the hard work out of it. And I believe we had one more, which was f of negative 2. So f of negative 2. And if you want to just go back in here and just change the value, it will calculate it for you. F of negative 2 is going to be 16 as well. And you all may be thinking, hey, Mr. Williams, why is f of negative 2 the same thing as f of 2? And I will show you. When you are going to do when we start working with powers and exponents and things of the sort, you want to make sure that when you write them outright. So this is f of negative 2. What that means, when we plug it in, this negative 2 squared, that's going to be 3 times, and don't forget these parentheses are really important with this piece. If you don't put the parentheses, then you won't do the math, it won't do the math correctly. 3 times negative 2 squared. This negative 2 squared, let's go ahead and get rid of that 3 for a second. This negative 2 squared is the same thing as saying equals negative 2 times negative 2. That's what that squared means. That squared means we're going to multiply whatever that base is, however many times that exponent says. So this says negative 2 to the power of 2 squared. So we're going to multiply that negative 2 times. And negative times a negative is a positive, and that's how we ended up with the same positive 16. Okay, that's how we did that one. Let's look at number 7. Number 7 says, if f of x equals x over 3 minus 4, make a table, then state the range if the domain is -6, -3, 0, and 3. All right, so here I'm going to pull up good old Desmos again because, it's a tool to use. Let's use it to the fullest. So once again, I'm going to go ahead and type in that function. We've got f of x equals x over 3. Oops. And if you want to do that division bar, you hit the / on your keyboard, and Desmos also has an input for that there. X over 3 minus 4. Okay. And now it's asking us over here to make a table if the domain, in case you don't remember, our domain is our x and our input. Okay. X and our input. To do that, let's go over here back to Desmos. And what we can do is we can hit this plus button up top. It'll say add an item. We're going to click that and then table. This is asking us for a table. So we're going to, it says make a table. So we're going to set it up to use a table. So this we can keep as X, backspace so it doesn't save that sub one underneath it. And then instead of Y1, we're going to put F of X since we already wrote that as our equation to get started on. And so now what we're going to do is enter these values right into X, -6, -3, 0, and 3. So here we go, -6, pow, -3, pow, 0, pow, 3. And here we go, we see that it has given us our table. So all we need to do is just like draw our table over here on the Kami document. Boom, there we go. Desmos is this awesome, 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 powerful tool that we can use in class, okay? All right, so if you get stuck with the computation stuff, the working things out, go ahead and open up Desmos and start using it. And I'll do, when we go over more of these classworks, I'll show you all how to use more of Desmos the more we do. All right, so the last problem I'm going to go over is number 10. 4 points of a relation are shown below. Plot one additional point so the resulting relation does not represent a function. So we're working with relations again, and we're trying to see whether we're trying to make this not be a function. At the moment, it is a function. This is something that would pass that vertical line test. I'm going to just make a vertical line as vertical as I can get it. I can't get it to 0. Oh, there we go. All right, so here we go. And I'm just going to go ahead and run this thing across my graph. If it touches more than one point at a time, then we know it's not a function, but it is a function. So to make this not a function, we just need to make this line here touch 1 point. All right. So we can just draw in a point. So I'm going to go ahead and click my draw tool. You don't have to draw on the same point I draw on. You can draw on any point. Let's go with, well, I'm here. So I'll go with that. Okay. So now that I've drawn a point and made it so this graph does not pass the vertical line test, this thing is no longer a function. Okay. So I know I went through that a little fast, but if you get stuck on a part, go ahead, rewind it, play it at a slower speed so that way you can grasp the material. If you are still having questions, by all means, please come and ask them. Okay.